Hey there, chemistry students. This is Miss Ruark. This is podcast 9.4. We're going to talk about salt hydrolysis, or what happens to salt or ionic compounds when they are placed into water and how they dissociate and come apart. And this is important because this is what happens with some acids and some bases, and that's how they produce acidic or basic or neutral solutions. And so we need to talk about this. Okay, so some of our aqueous solutions can be acidic, some are basic, and some are neutral, but we don't know why. Well, let's talk about this. We know that salt reacts with water in a process that we call salt hydrolysis. Okay, so what does salt hydrolysis mean? It just means that the salt in water, a salt compound or a salt, will break apart or dissociate into the ions that make it up. So some of them will dissociate completely. We've talked about those. We call those strong acids and strong bases. But we can also refer to them as strong electrolytes. You've heard the word electrolyte every day. You hear about them talking about electrolytes being in Gatorade and Powerade and different sports drinks. Those electrolytes are those ions that you need in order to let the muscles function properly, right? Well, some of them are going to dissociate only partially. We call those weak acids, weak bases, or weak electrolytes. When they dissociate, the anions from the dissociated salt are going to take hydrogen ions away from the water, and the cations from the dissociated salt can actually donate hydrogen ions to the water if it breaks apart and forms hydrogen. So it can donate those hydrogen ions to water. Okay, so here is a video that shows how something can dissociate. And this right here is table salt. And you got your sodium chloride, which is sodium ions and chlorine ions. And right here are salt shakers dropping those into the water. And the water molecules have a polar end, right? A positive and a negative end. So you have your oxygens. Here's your positive ends, and here's your negative ends. So your positive ends, the hydrogens, are attaching themselves to the negative chlorines, and the oxygens, the negatives, are attaching themselves to the positive. Right? And that's how they pull apart. Well, eventually they all completely pull apart, and that's when it dissociates or dissolves into solution. And that's pretty much what happens when an ionic substance is put into water and it completely dissolves. Okay, so why do we need to know this? Well, salts that produce basic solutions are usually coming from a strong base that reacts with a weak acid. A strong base that reacts with a weak acid. An example of one of these would be if we had NaOH, or sodium hydroxide, reacting with acetic acid. Okay. Those two coming together would form water, and then we would also have our sodium acetate. Okay. So then if I asked you, well, here's our salt, what kind of a solution would this be sitting in? Well, you would assume that it's sitting in, of course, an aqueous solution. Excuse me, and we would go backwards. So if it's sitting in an aqueous solution, we go backwards to form our weak acid and our strong base. And based on weak acid, strong base, the strong base wins, and it's a basic solution. All right, so what about salts that produce acidic solutions? Well, those are formed from strong acids reacting with weak bases. Okay, so an example of that would be H2SO4 plus NH3. Okay, H2SO4 and NH3 would eventually come apart. We're not going to break it down, but it would come apart to form water and a salt that would give us an acidic solution. So weak acid, this is a strong acid. What am I doing? Strong acid with a weak base to form an acidic solution. Okay. And then for our last one, we have a neutral salt. Well, a neutral salt is going to be something that's from a strong acid reacting with a strong base, or a strong base reacting with a strong acid. Whoa, went too far. An example of that would be sodium hydroxide plus hydrochloric acid will give us sodium chloride and H2O. Okay, this is going to be a neutral solution because it's a strong acid and a strong base that completely dissociate or break apart. Okay, so just some examples of how we're going to use this in class tomorrow. we know that we have a neutralization reaction that produces ammonium nitrate and water, or it could say an aqueous solution of ammonium nitrate. And we want to classify this as acidic, basic, or neutral. So we need to go backwards. We need to figure out ammonium nitrate, and it's an aqueous solution, which means it's in water. And we need to figure out, well, what made up this ammonium nitrate in this water. Okay, so the water breaks apart into H's and OH's, right? And the ammonium breaks apart into ammoniums and nitrates. And hey, guess what? It's a double replacement reaction, so let's just go backwards. So we have ammonium hydroxide, and we have nitric acid, and then we just look and say, well, ammonium hydroxide is actually going to be a weak base, and nitric acid is going to be a strong acid, and so this would be an acidic solution because strong acid, weak base. That's all you got to do. All right, so here's another one. A neutralization reaction produces potassium sulfate, K2SO4, and water. Okay, break this apart into potassiums and sulfates, right? And this breaks up into H's and OH's, and we go backwards. Oops. So we have KOH and H2SO4. Don't forget it's H2SO4 because this has a -2 charge. Okay, this is a strong base and this is a strong acid, which means that this is going to be a neutral solution. Okay, hopefully you're catching on by now, and if you're not, hopefully this last one will catch you on, and then we're just going to practice this all day in class tomorrow. All right, so we've got one that produces calcium carbonate, CaCO3, and water, H2O. And so I'm not going to break it apart for you this time. I want you to see if you can figure it out on your own. All right, so this is going to produce calcium hydroxide and carbonic acid. All right, and then calcium hydroxide is a strong base. Carbonic acid is a weak acid, so this would be a basic solution. Okay, and I think that's it, guys. I don't think I have anything else. So very nice, quick, short, sweet, and to the point, and I'll see you in class.